Welcome to this educational video on the stereochemistry of atropine. What is stereochemistry? Stereochemistry is a branch of chemistry that deals with the three-dimensional arrangement of molecules in space. The importance of the stereochemistry is synthesis of drugs. Isomers are two or more compounds that have the same molecular formula. Types of isomers. Isomers are divided into constitutional isomers. They have different connectivity of atoms in their molecules. And stereoisomers. They have the same connectivity of atoms, but different in the arrangement of those atoms in space. Types of stereoisomers. Stereoisomers have two types, configurational isomers and conformational isomers. Classification of stereoisomers. Stereoisomers are divided into enantiomers, which are non-superimposable mirror images of each other. Diastereomers, that are not mirror images of each other. And mesocompounds, that have more than one asymmetric carbon and that is superimposable on its mirror images. Now let's talk about atropine. Atropine is a natural alkaloid anticholinergic agent with potent anti-muscarinic effects. It is used by injection to treat symptomatic bradycardia, severe bronchospasm, and to reduce vagal stimulation. It is also used as an antidote to organophosphate poisoning and certain types of mushroom poisoning. Atropine is a tropane alkaloid, a class of organic compounds that contain a tropane ring structure. It is a racemic mixture of D and L-hyoscyamine, of which only L-hyoscyamine is pharmacologically active. The chemical formula of atropine is C17H23NO3. It is from the Solanaceae family. Atropine is an antimuscarinic agent. Its boiling point is atomic weight 289.37 g-mol. Atropine should only be used under the supervision of a healthcare professional. Stereoisomers of atropine. Levo and dextro. Levo is called levohyoscyamine, and it is active, while dextrohyoscyamine is not active. Those are the structures of levo and dextrohyoscyamine. L-atropine hyoscyamine has a levorotatory optical rotation and is designated as the L isomer. It rotates plane polarized light to the left. D-atropine hyoscyamine has a dextrorotatory optical rotation and is designated as the D isomer. It rotates plane polarized light to the right. In terms of activity, the levo isomer is active while the dextro isomer has very little activity. In terms of their pharmacological properties, L-atropine and D-atropine have similar effects on the body. They both act as anticholinergic agents by blocking the action of acetylcholine, a neurotransmitter in the parasympathetic nervous system. This leads to various physiological effects, such as dilation of the pupils, increased heart rate, decreased salivation, and relaxation of smooth muscles. Mechanism of action of atropine. Atropine binds to and inhibits muscarinic acetylcholine receptors, competitively blocking the effects of acetylcholine and other choline esters. It acts as a reversible nonspecific antagonist of muscarinic receptors, showing affinity for the M1, M2, M3, M4, and M5 receptor subtypes. Atropine antagonizes the effects of acetylcholine on tissues innervated by postganglionic cholinergic nerves, such as smooth muscle, cardiac tissue, exocrine glands, and the central nervous system. It acts in less innervated smooth muscle that responds to endogenous acetylcholine. The actions of atropine can be overcome by increasing the concentration of acetylcholine at receptor sites, for instance. The use of anticholinesterase agents that inhibit the hydrolysis of acetylcholine. And those are some trade brands which are available in the market. Thank you for watching.